Good afternoon, everybody. We should be live going on with the show. Yes, uh, and we don't have an URL for today because we are starting a new section on the Ether data type. Let's see how it goes, and yeah, let's get started. So we have the Ether data type section 4.4, and there is of course, the elaboration on the topic by the authors. And there is this code that we are going to copy paste. Copy. Where is it? Yeah, we are starting this new section. And yeah, okay, and here again we are calling my either, which is their either because it's their code, but they are it's okay. And then there is some examples over here. Look at this, and then we have this generic function that we are going to copy paste. And I did take time. I took the time to read this little section, this paragraph, before the live stream. Then I was thinking, will I be able to solve it? Are we be able to solve it? And then the exercise out in your face right away, which is great. And it says this function is general enough to be defined on the Ether companion object since it's not tied to a single use case. So let's do that. My either. Yeah, let's see how it goes, and then worry about the type annotations. Okay, try. And over here we will require this import. Okay, because the non-fatal. Okay, do you think this is good to generate a URL? We have our first errors. How my either? Yes, because we changed over here my either. So let's generate another thing. And since this time it worked. Now, yeah, we do have a starting point. Yes. Now about these functions, you already have seen this all over the book so far, but this time we get to define them for the Ether data type. And again, we decided to go one by one. Let us see the time, 4 minutes. This is the starting point, so it's okay to have this amount of time at the beginning we are setting up the things. It seems that these are inside the enum because we have over here some that, look at this, that, so we will doing some comparisons, like if you have worked with another programming language like Java, you will have these, compare that, for example. With this, you'll be able to be inside and then implement the function, define the function, and uh, coming up with some examples to test the function. So let's and I am not sure about this how it will how we will be doing this, the inner workings for my Ada. It's we now have a value in the left in the option data type. We only have some value and none. Now we have another value, but we should be able to duplicate the thing. So let's write map. Okay. Mm, yeah. How can we do this? We should, since we will be calling this map for my either value, we should be able to do this. So and over here we don't have any constraints about pattern matching, or it is not required or invited. We are not invited to terms to implement the functions in terms of the other, so we can use pattern matching. This match case. Look at this. We have Scasti is giving us the code, which is great. Let's accept the thing. And if it is an error, but I don't know, maybe you want to, if you want to come up with the entire code, maybe you should be using our Debian over here and write the entire code over here, including this, so we don't have the suggestions. But for me, it's cool. I don't have any problem. It's quite obvious that you will be matching all this, but it's up to you if you want to do this on a Scasti or in the REPL directly. 10 minutes. Okay, right. Value. Here I'm using error. And Now we have a value of type A. Look at this value, type A. We can apply this function. If we leave this application as it is, we are getting a B, as you can see here, and as you can see within casting. And we need my either, so we need to wrap the thing inside the right. And over here, I am not quite sure about this, but I'm just propagating the error. Same value. This is map. Now let's print, are we done? Or is that it? I don't know. I am seeing that Scala is quite, the compilation is faster, you know. Yeah, now how can we test this map? And for the next ones, probably will be tomorrow. We will starting from here, from the last URL generated URL, and it will be available in the video. We have for drawing. How can we test this? There is some code over here. So I'm going to try one of these. We will exercise this example when we have flat map, because this is a for flat map application and map application. So, you know, h2 int. What can we? Let's get rid of this. Okay. Yeah. What can we do over here? Either catch non-fatal, which is my either for us. My either. Sometimes these things. Okay, here it is. Oh my god. My either. What happened? Either. So it's only the. What should we? Either. Catch. Catch non-fatal. And we're going to try 7. This guy from Scasti has this opportunity to infer the to int, because we have a string. We have a string over here, so they can you know, come up with the suggestion to int. And say, since we are getting an either, my either, we can say map times 7 should be 49. Right, 49. And if we say t, some number format exception, that is we have uh, can catch non-fatal, and the exception, and map when over this branch. So it's okay. So we have a working thing. Oh, E. And now it should be 49 and error. Okay, we are done. 15 minutes. Yeah, that's cool because we did the setup. And sometimes I say to myself, maybe people just want me to shut up and write code, but what's the point of that, Uh, but yeah, this is all about it. I don't know if I can add something. Sorry. So we have imported control non-fatal. For this, this case, we have to find my either, which was from the book. It has two cases, left value and error, and right. This is from the book, Then we have our ubiquitous map function that and love. And we apply f to the value of type A, and we get a right. If we don't, we propagate the error, let it be. And we exercise the thing with some snippet from the book. 7 to in map 49 left. I think it's quite straightforward. Thank you very much and happy weekend. See you probably tomorrow with the next one. Thank you very much. Bye.